Welcome back to the Linux Academy Nginx Deep Dive. In this video, we're going to continue with where we left off talking about load balancing within Nginx. And we're going to see how we can change the way that the load balancing is done. And we're going to do that mostly by looking at the docs, but it's going to be something that we can implement into our photos.example.com upstream directive that we already have. So if we head over to the documentation, you'll see that server is kind of our main thing here. And I mentioned in the previous video that we can manipulate how Nginx goes about sending traffic to the various servers. And there are two different ways. We can modify server so that it has a little bit of extra information. And then the other way is by changing the actual load balancing method that exists. And there are multiple directives in here that are related to just that. So hash is a way of determining where traffic should go based on a key that you set up. And you can make this key using some form of static information or using the variables that we've seen so far. So this key value could be something like the $request URI variable that we've seen in the past. And what that would actually do is the first time it comes through, Nginx would see that request URI and direct it to a server. And then the next time that comes through, it would try to direct it to the same server. As you can imagine, there are things you could do here that would kind of potentially ruin the load balancing aspect of things if you decided to use it this way, because you could route all of your traffic essentially to one server instead of spreading it across if you have one page that gets the majority of your traffic. But on the opposite side of that, though, you could intentionally route all of the traffic that's going to say something like your admin area to one server so that your admin requests don't degrade the performance of your actual consumer requests that are going to the public areas of your website. So hash is one of the available load balancing methods that we've got. Additionally, we have IP hash, which is going to take the first 3 octets of your IPv4 address and route those to servers. So what this means is the client IP address. So if you have a bunch of clients that are on the same network, then they could be routed to the exact same server. So once again, this is something that you could do to intentionally route some traffic to one server instead of another. But you could run into a situation where you're overloading one server. And the last one that I want to look at is going to be least con. And the way that this works, and it doesn't take any arguments, similar to how the IP hash didn't take any arguments, is it will simply route the request to the server that has the least active connections right now. In theory, this could have the same result as a round-robin approach, but depending on how long some of the connections end up lasting, it will route the traffic to the one that is currently dealing with the least amount of traffic. If we wanted to use one of these, how would we actually go about changing the load balancing method that we're using? We can make this modification by using one of the directives that we just ran into from within our upstream block. So if we wanted to use the IP hash version of this, we would simply utilize IP hash right there. And for something that has an argument like hash, you would do it like this. I would suggest putting them at the top because it doesn't really matter if it happens before the server portion, but there are some of the other directives, specifically the keep alive portions, that you need to reference what you're actually going to be using as your load balancing method before you see a keep alive directive. So I would always put the load balancing method at the very top, and then you can follow it with your server and any other configuration that you might want to work with. So just to cover that once again, the ones that we have that we can use are the default, which is if you don't specify a load balancing method, you get round robin. Otherwise, we have least connection, or IP hash, or hash. You will notice looking through the documentation that there's one called least time, and that is another load balancing method, but it is once again part of the Nginx Plus offering. And that one actually routes based on the average response time that it's getting from servers. So it's trying to route things based on the perceived performance that it's going to get based on going to a specific server. For our Photos application, we're going to continue to use the default round robin type. But the other way that we can manipulate how the server is going to go about sending traffic is by using some of the optional attributes to the server here. So in our hypothetical situation here, all of these servers are running on different machines, and maybe we know that Web Client 2 and Web Client 3 are both slower and they can handle less traffic. So in that case, we want to prioritize sending traffic to our first server, and for that, we can use the wait parameter, and we can set it to anything higher than 1, and then this server will be higher prioritized than the other servers because the default wait for any server is going to be 1. So if you have a very complicated set of things where you want to prioritize all of the servers and you can actually rank them based on hardware specifications that you know or just load that you expect them to be getting from maybe other sources of traffic, then you can specify wait on all of them. So this is one thing that you can do. If we look at how the actual server directive works, we can see that it has parameters. And that's, really, there's just kind of a number of them. Some of them, once again, you'll find are only usable if you're using the commercial subscription. But the ones that you'll see most often are going to be wait, max connections, which allows you to specify the maximum number of connections that you're going to send to a server from the load balancer. And this is another one that would be usable if you knew the performance characteristics of the server and you just understood that maybe it can't handle more than 100 clients or something like that. The backup sets up a server as a reserve server for only being able to receive traffic if the primary servers are all unavailable. There's also down, which just marks it as unavailable, and Nginx will not change that from not being down. And this is something you could do if you were going to do some maintenance on one of your application servers. You could come into your Nginx reverse proxy server and modify this so that you just took that one out of the load balancer manually, reloaded your configuration, and then no more new traffic would be sent to that server. But the ones that I want to talk about for the remainder of this video are going to be used in what is called passive health checking. So there's a way to do active health checking where you're continually monitoring the health of something. But the passive way of checking the health of a server would be basically waiting for something to fail. And max fails and fail timeout are two of the parameters that we can send to our servers that allow us to add passive health checking. So we're going to set both of these to max fail of 3 and fail timeout of 20 seconds. What this specific setting is going to do is going to tell Nginx that if we ever receive 3 failed requests within a 20-second period, then you should automatically mark this server as being unavailable because something's going wrong there. So that could be something going wrong in terms of it's just overloaded, or it's actually just having, some sort of catastrophic failure, but it will remove the server temporarily so that it can maybe get itself back on its feet. And the fail timeout specifically, this one kind of works in 2 ways. The 20 seconds here sets the duration that we will check to see if we get 3 failures. So if you get 2 failures in 20 seconds and then you get a third one at the 21-second mark, then it's not going to actually fail in this case. So the 20 seconds is going to be where we have to get 3 failures within a 20-second span. Then Nginx will mark this server as unavailable, which is like marking it as down, except for Nginx will put it back into the pool after 20 seconds has occurred. So this is the duration that we'll check to see if the number of failures occurs, but it's also the timeout that we're going to give it if it does have that many failures. So these 2 parameters in connection with one another are how we can add passive health checking to our servers within our load balancer. And then prioritization, we have wait, and then we also have max connections to say that we don't want to send more than, 1,000 requests to a specific server, and that way it will know that it needs to prioritize going to the next server that has the available connections. To recap what we talked about, there are 4 different ways that you can actually route traffic, and that's through load balancing methods there, and that's going to be the round robin default, IP hash, hash, and least connection. And then you can further manipulate how these individual load balancing methods are going to go about routing traffic by adding waits and max connections to set whether it should prioritize one server more than another server. And lastly, we talked about how we can add passive health checking to servers within our load balancer using the max fails and fail timeout parameters.